A mega tsunami is a truly terrifying event. Thankfully, they're quite rare. It takes certain specific conditions to generate them. But in general, the predominant ways that they will be created is following a landslide, meteorite strike, man-made explosive detonation, or large-scale caldera-forming volcanic eruptions that occur near to or directly impact a large body of water. I might be missing a few other ways, but you get the idea. Massive splashes, basically. Something like this occurred in Lituya Bay, which is located in Alaska, in 1958, when a gigantic 524 metre or 1719 foot high mega tsunami was created after a magnitude 8 earthquake dislodged a massive amount of rock on the side of a cliff face, which fell directly into the bay below, spawning a tsunami that was truly the stuff of nightmares. So in Australia, we have widespread evidence of a truly cataclysmic impact event that happened fairly recently, and an associated mega tsunami which inundated almost all parts of the western and southern coastlines of Australia. A large comet slammed into the deep waters of the Indian Ocean, and it's thought this comet fractured into 3 pieces, 2 of which were much smaller and appear to have landed in different spots in the Pacific Ocean, making this a global event. And the reason we know this is because the rainout from these impact centres overlaps with the ones in the Indian Ocean, as this event also caused a worldwide deluge that lasted for weeks on end, as it vaporised an incredible amount of seawater which, upon impact, was converted into an immeasurable amount of water vapour that would then go on to travel with the prevailing winds around the globe, taking several days after this event to finally cool down based on studies. And the link to this study will be located in the description below. But after this water vapour finally cooled down, it would finally be rained back down to Earth in a truly biblical proportion kind of rainstorm. And biblical proportion might just be the best way to describe it, as this rainstorm coincides with the flood stories that were told globally by over 150 different cultures. This comet was a Shoemaker-Levy type of impact. The comet Shoemaker-Levy 9 broke apart in July of 1992. And it collided with Jupiter in July of 1994, providing the first direct observation of an extraterrestrial collision of solar system objects. This generated a large amount of coverage in the popular media, and the comet was closely observed by astronomers worldwide. So the collision that occurred in the Indian Ocean was caused by a comet similar to the one that slammed into Jupiter. It's a comet, not an asteroid. The difference is an asteroid is made up solely of rock, whereas comets are a mixture of rock, ice, and gas. If this was an asteroid, the impact would have been far, far worse, especially if it was a heavy iron-rich asteroid. The mega tsunami would have probably been at least 1 kilometre high if that occurred. The capital city of Western Australia is Perth, and as of today, it has close to 2 million people living in this city. It's one of the many places that were built atop the remains of the deep sea sediments that were dredged up and carried over here by the mega tsunami following the collision, which, by the way, left a 30-kilometre wide crater after the comet had struck. But when it collided with the bedrock of the Indian Ocean, sand, mud, volcanic material, and whatever else existed on the almost 4-kilometre or 2.5-mile deep section of the Indian Ocean where this comet struck, got blown out in all directions. A large part of it was thrown into space as well, but the majority of it would be carried by the mega tsunami that was generated, only to be dumped here en masse 5,000 years ago following this event, changing the entire landscape literally in the blink of an eye, by converting the previously flat land into a landscape dominated by sandy hills that were comprised of deep sea fossils, mud, and obviously, sand. Core samples taken from these sediments feature deep sea microfossils that are fused to extraterrestrial metals, and these metals could have only come from this type of event. So in this video we're going to nerd out on the geography of Perth as it pertains to the sediment left over by the mega tsunami that now dominates the surface layer and the expression of the land for many tens of kilometres. A really massive area of land was affected by this tidal wave of truly epic proportions. It swept inland for many kilometres, and it would have been a truly terrifying event to have witnessed. And if you're unlucky enough to be in the immediate strike zone, the chances of surviving this type of event are next to none. The evidence that we have of it are in the form of the arrow-shaped depositions that are left behind following the retreat of the mega tsunami, known as chevrons. These chevrons are actually how we found the impact crater to begin with, by studying which directions they went and tracing them back to their source. after which deep-sea seismic imaging was conducted in the vicinity where scientists thought it may be by ship until the crater was finally found. The cool thing about literally every single town that's built along the coast in Western Australia is that they are all built within these chevrons, blending mankind with the remains of a landscape forged by a truly destructive event, which deposited sediments at a vast scale across the coastlines of Australia. And you can clearly see the effects of it from Western Australia all the way to Tasmania. And I'll cover this in depth in my next episode, and there are some truly spectacular features up and down the entire western and southern seaboard, and on the eastern seaboard there are some unrelated mega tsunami chevrons. So the waves would have absolutely inundated this area when the tsunami first struck, with a very conservative minimum height of 150 meters or 492 feet being attributed to it. Most studies think it was around 180 meters or 590 feet when it reached the shorelines of Western and Southwestern Australia, and that sounds about right. This wave went as far inland as 30 kilometers, and in some areas it went further than this. And the force of the initial impact when the massive wall of water struck everything would have been unimaginable. In some areas, entire cliff faces have been severely eroded to a dramatic extent by this single event, and in the northern parts of Western Australia, scars exist across large areas of the arid land, which have recorded this event better than anything else because of the climate. And whilst we will be covering this in the next episode, here are some pictures of the scars left in the land as a teaser. You can clearly see the direction they were travelling. So if this event happened today, the entire city of Perth would be drowned and destroyed faster than most could imagine. And the wave would travel over the entire city, stretching all the way up to the limits of it, waning in its power most at the beginnings of the ancient cliff face that is comprised of over 2.5 billion year old rocks from the Archean Eon. These cliff faces start about 30 kilometers in, and it more or less broke the wave and stopped it from going too far inland. So if I was to quickly throw over a geological map of this area and take a guess at which layer this tsunami deposit is, I'd say it's either been broken up into two, so it's either both or one or the other in my opinion, but in the description for both the Yogyanup Formation and the Bassendean sand layers make mention of dune quartz sands and heavy mineral concentrations existing, pointing to these two as being the layers. And that would make sense because they are slowly being overlain by the more recently deposited sediments of the Guildford Formation layer, which is the most recent alluvial sediment. Now check this out, this is literally the entire extent of the wave in the grand scheme of things. Look how clear the difference is between the mega tsunami sediment strewn land and the cliff face all along the west coast. This is a rough limit of the mega tsunami. Water did move past here, as based on topographical data, these cliffs are between 124 all the way up to 331 meters, or 406 to 1085 feet in height, with it rapidly changing in topography between the drastic dips in elevation that you see. So we can see some chevrons that have moved past this point, but it's unlikely it really went too far beyond this peak over here. So interestingly and rather unsurprisingly, Perth's topography acted like a beautiful little funnel for this event, which would have contributed to the height of the mega tsunami as it began to ramp up and narrow as it entered through the funnel. Meaning the waves more than likely would have reached their highest here due to the funnel-like topography of the area. So it's actually possible that I'm wrong and that the wave was way higher and went way further. And there are chevron-like shapes that do go inland for many kilometers beyond this point, but I don't know for sure if they are chevrons or just chevron-like shapes from past tectonic events, with geological maps not really helping. I'd actually have to go here in person and take a look for myself or have someone to do it for me. So in general, Perth is about 30 meters above sea level. If a wave at a very conservative estimate of 150 meters hit this area, well, you can do the math. That's 120 meters, or 393 feet worth of water covering you in an instant, smashing you at a bone-crushing pace when it makes contact, thrusting you into a watery chaos of pressure-induced insanity, taking you along with it for a very violent, tumultuous, and bumpy ride, and death. Poor animals, man, dead set. This would have taken so many animals along with it, and it would have more than likely impacted many indigenous communities too. What an intense and scary event. I'd love to know if any stories of it exist within the local tribes. In Perth today, you can really see the chevrons in the actual city itself. Here's a few over here near Allen Park. The chevrons are really significant on the edge of the beach, and here are some houses that are built into the actual chevron. And look how white these freshly exposed sediments are in these new industrial complexes. This is all deep sea sediment from the 12,500 foot or 3,810 meter deep sea floor of the Indian Ocean where the comet struck. Here we have what appears to be a slide of fine sediment which was thrown across the land rather spectacularly. I'm assuming this happened because it is the lowest topographical point in the area, where the most significant amount of sediment slid tens of kilometers inland. You can see the layers where it was deposited the most. This is Bold Park. It contains the chevron shapes that once would have existed everywhere on this land before it was largely leveled to build a city. So because of this leveling, you might think things don't appear to be that bad, until we get to this point, where habitation and the alteration of terrain hasn't yet commenced on a grand scale, and we begin to see the size and extent of the chevrons that buried this entire area. On the topography, some of these chevrons are between 40 and 90 meters, or 131 and 252 feet in height. Towns are built around them in the lower lying areas. The arrow shape is ever so present everywhere here to a grand scale. This is the type of stuff that Google Maps or Google Earth would have a hard time conveying, and this is where this simulation shines. So these events are truly destructive, as we will learn in the coming episodes, where we cover not only the mega tsunami damage but the deluge that followed. Let's pray that we are on top of any potential impact event that could create another scenario like this one that occurred 5,000 years ago, that our ancestors across the globe somehow survived through, with much difficulty. And I suppose we should thank those guys and gals who did. It's because of their sheer tenacity and utter willpower to survive that all of us are here today. So this is the violent story of how the land that Perth sits atop was constructed. A once flat land suddenly made mountainous after being buried by a huge tidal wave, more than likely stretching far beyond the conservative 180 meter tall mark due to the aforementioned funnel here. In fact, I've tracked what appears to be chevron-like structures up to 100 kilometers inland in some very flat places. One day I'll go there in person to check them out, but the entire land here was dramatically altered after the waves finally receded. The death toll inflicted on life here must have been truly depressing to see, being surrounded by nothing but death in a place that was once home, but that now looks like an alien landscape, dotted with weird muddy sandy hills that are scattered everywhere and that are filled with alien metals fused to deep sea fossils. This was a sad day, but unfortunately it was just the beginning, because the rainstorms that would follow in the coming days are what would really turn this horrible situation way worse, and the death toll to both humans and animals are about to notch up from regional disturbances to one that affects life planet-wide as a result of this. When a comet collided with a deep section of the Indian Ocean around 5,000 years ago, the mega tsunami that was generated absolutely inundated and decimated the shorelines of every continent that was within the direct reach of the impact crater. From Africa to the Middle East, to India, Asia and Australia, every continent bears the marks from this event, either in the form of deep gashes carved into the bedrock of the land that stretches for kilometers, or in the massive arrow-like hills that are left behind following these types of massive mega tsunami type of events, known as chevrons. Some places bear the marks more than others, with more clear and easier to see visual evidence occurring in places that are more arid and that contain little vegetation, such as here in Western Australia, and in places in northeastern Africa, like here in Somalia, where we can see the deep carvings in the land that were etched with force by the severe erosive action unleashed by the unfathomably tall tidal wave that slammed into here at one point in time in history. In our last episode, we discussed the damage and present-day evidence of this mega tsunami that exists within Perth, the capital city of Western Australia, which was absolutely hammered when this mega tsunami made contact with this area, and was especially affected as a result of its funnel-like topography, which would have increased the ramp-up height of the mega tsunami as it made contact with the land. I discuss the evidence, including what physical changes to the land this mega tsunami event left behind, and I teach you what they look like and what to look for in that episode, and it's best to watch it before this one as a result of that. The link to it will be both in the description down below or on the top right of the screen. In this episode, we'll discuss the damage that was inflicted to Victoria, Tasmania, and the islands between the two, of which some incredible destruction was wrought on the coastline of pretty much all of these places. I was originally going to do the rest of Australia all in one video until I realised that damage from this mega tsunami was so widespread it turned into a 30 or 40 minute video, so instead I've decided to break it up into two. This episode will focus on Tasmania, Victoria, and the islands between, and the next episode will cover South Australia and the significant damage found in the northern parts of Western Australia, as well as what occurred in the south. The damage inflicted to Australia was widespread following this event. There were very little places that were spared, with only a few sheltered locations existing in a few areas here and there, such as this one in Western Australia just south of Perth, which was sheltered from the direct impact of the mega tsunami wave by this piece of land here, that jutted out and served as a shield, taking the main impact of the wave instead. Vegetation is lush here, so it's harder to see, but the tsunami left really deep gashes. This area is topographically high too. This part is literally around 150 meters, and look, the wave flew right over it. That's how high this freaking wave was. Scientists believe it was around 180 meters in height. In South Australia and Victoria, the entire land was smashed, including the islands between Victoria and Tasmania, such as King Island, which has several places that were severely impacted by the initial wave. And many of these places include large chevron depositions, such as this obscure little location here, on this tiny little island in the northwestern part of Tasmania, along with many depositions in the lower lying areas of the western coast of Tasmania. So let's start at Tassie and work our way up, documenting the evidence that can be found on the coastlines of every place we see. Our evidence of the mega tsunami strike begins here in the southernmost section of the west coast of Tasmania. This is a very interesting spot because only one area exists that has very clear and distinct chevrons and directional wave damage, with a second lesser affected spot that only hints to what occurred. The rest of this part of Tasmania doesn't have a single bit of evidence. Why? Because these islands blocked it. Look at the evidence on them instead. It's clear that Madagascar Island bore the very main brunt of the wave impact here, as the entire island is dominated by chevrons, and it was heavily altered following this event as a result of this. The waves hit here, and this is the second less obvious spot, a very high cliff face, that shows the erosive visual pattern of a very large wave impact and retreat, along with the aforementioned spot here, with clear chevron deposits. So moving on to the western coast of Tasmania, and here, even on Google Maps or Google Earth, you can see the areas affected by the mega tsunami by just looking at the directional strips of bare sand that exist. This, to me, is a telltale sign that I've seen time and time again all across Australia and even the world. These little sandy strips that just kind of pop out, and they're always in the direction that the wave would have travelled from when the comet impacted the Indian Ocean. And when you don't see them, it's because they've been blocked by some kind of island or obstruction that bore the brunt of the direct impact instead, such as what happened in this area here. The clear evidence that we have of the mega tsunami hitting this region is of this deep sediment dump over here. Notice the direction of it. The wave hit from this angle, so there's parts where sediment was deposited in such a vast amount that vegetation still hasn't regrown on all of the chevrons deposited here, with other parts of it being dominated by plant growth. Now check out what this wave has done to the surrounding mountains here. It stripped them bare and carved into them in a directional manner, leaving these deep scathing tears in the land, which were engraved as a direct result of the force of the impact and the subsequent water movement following it. The major erosive forces altered both the land and the bedrock immensely after this event occurred, as it literally tore into these mountains and scalded them in a near instant. you can see how they differ from the more natural erosion channels that the other mountains here have, such as these ones over here. This area bore the direct brunt of the wave, and look how deeply incised it has become as a direct result of that. Now, this is just speculation, but it's a pretty solid theory in my eyes at least. Based on the scarring of the land, it appears the wave hit from this angle, hopped over this lower part of the mountain range, and followed it all the way through to the other side, leaving behind these massive cuts in the mountain that normally wouldn't be there without this kind of event happening. Also a theory, but at Tasmania's most southern point over here, we have these deep nashes dug into the bedrock here, which are also facing the same direction that the mega tsunami wave travelled, and whilst their existence might not be attributed to it directly, I'd be willing to bet a part of my manhood that a significant amount of the present day look of it and the erosive direction are directly related to this mega tsunami impacting it, and significantly eroding it, as this entire stretch of land has dozens of west to east oriented tears in the land created by the erosive action of the mega tsunami waves as it travelled over it. It probably completely stripped the sides of these places bare of the topsoil that once existed here and held this place together, significantly changing it in an instant. So as we move north, we can see the same directional chevron depositions and carving of the rugged mountains that dominate the western stretches of the beautiful ancient land of Tasmania, which is around 1.5 billion years old by the way, making it a billion years older than Victoria, New South Wales and almost all of Queensland. These chevrons mainly got deposited in the lower lying areas, and as we move on to the northern tip of Tasmania, we see a rather large fan shape in which a vast amount of chevron accumulations were deposited after the massive 180 odd metre high wave ripped through here. As we move north from Tasmania, here at Trefoil Island, you'd think these massive 80 metre or 260 foot high cliff faces would be enough to kinda shelter it, but nope. Check out these deep nashes that exist. So we know the wave was at least 80 metres high when it reached here, but based on this evidence it was much higher. Obviously it was still around the 180 metre high mark when it hit this part of Australia. This is Hunter Island. It's a pretty big island in northwestern Tasmania and it was absolutely smashed by this mega tsunami. Check out the massive wave damage that's still clearly visible. You can see this on Google Earth too, and you can see it very easily. This is because the island's highest peaks are the two bumps on the eastern and western side, and these bumps are between 70 and 58 metres high, so it's safe to say this entire island was submerged for a while when this tsunami strike occurred. On Three Hummock Island, we can see that not as much damage has occurred in the southwestern part of it as a result of Hunter Island bearing the brunt of the main impact, which sheltered these places. But as we move up towards the line where this sheltering no longer occurred, we can see the impact of the main wave very clearly. This occurred because the little section of Hunter Island that the wave passed over was only 40 metres or 131 feet high, and it was only a thin strip of land, so it did very little to absorb the force of the main impact, and Three Hummock Island did so as a result of this instead in these parts. At King Island, we have some really intense damage. Like the south is absolutely smashed and the chevrons are very pronounced. The chevron hills themselves can stretch as tall as 117 metres or 262 feet, meaning this once flat land was converted to a relatively hilly terrain overnight, with 17 metre high hills existing en masse all around you all of a sudden, pretty much in an instant. Imagine waking up in the morning if you were such a heavy sleeper that you somehow slept through and survived this event, maybe after taking 2 Ambien, only to be surrounded by sandy hills. You would definitely think you're tripping out, and that's probably why you shouldn't take Ambien. But as we move north, we see the same level of damage, everywhere. King Island would have been slammed, and I have a sneaking suspicion that the entire upper section of the island here was completely inundated and flooded. I see what appears to be chevrons from this event along with those typical direction orientated scratches that we see everywhere. Now you might think that from here we'd naturally move on to Victoria, like these are the only places that would have been hit, right? Nope. Flinders Island has these scars. The roughly 20 metre or 65 foot high island got inundated from one side to the other. At Victoria, evidence begins here at Wilson's Prom. The two tourist spots known as the Dunes of the Big Drift and the Little Drift are actually all one big quote-unquote drift created by this mega tsunami, and by drift I actually mean chevrons. It hit here very hard, and it passed over from the ocean into the Corner Inlet coastal bay. In the south, we see more evidence in a topographical low here, along with more chevrons. West of this, near Venus Bay at the Cape Lip Trap Coastal Park, chevrons stretch en masse from the south all the way up to and past Venus Bay. This continues up till around the Kulkunda Surf Beach, where it then stops. At this point, the wave damage doesn't become substantial until we go to Cape Otway, where the evidence starts and continues all along the coastline. The massive limestone cliffs that exist all along the Great Ocean Road broke much of the wave's main impact in most of the areas. With that being said though, the wave still easily scaled these cliff faces and it did sweep inland, but the strength of it was dramatically reduced and it didn't stretch as far inland as it would have had these cliffs not existed here like they do to such a pronounced degree. The lower lying areas, however, weren't as fortunate, and massive scars and chevrons do exist. We have places like here at Eyre River, where the chevron deposits can still be seen even with the vegetative growth. And check out the wave damage here that stretches inland for 3.5 kilometers. Insane stuff. At Johanna River, near the beach campground, we have another set of chevrons that don't reach quite as far inland, but that can still be seen even using satellite view on Google. As we move along, who knows how many apostles stood before this mega tsunami hit, but it was probably a lot more than the 8 that are left standing today as these beautiful limestone stacks. The steepness of these cliffs bore the brunt of this wave, and honestly I see very little impact evidence worth discussing aside from a few gnashes in the land here and there. So let's move along to the next place of significance, Warrnambool. Oh man, this place got slammed seriously. It's a topographic low of around 32 meters or 104 feet high, and geez, the chevrons here are amongst the largest in Victoria. Truly fascinating stuff to see. As we go west, past Port Fairy, the same chevron-like damage begins again at the crags. Continuing along at Cape Bridgewater, we see another series of major tsunami chevron deposits. This area is still recovering from the damage unleashed 5,000 years ago, and the deposition is so pronounced that the vegetation has still not regrown. Look at the clear direction the chevrons are travelling to. That's why we were able to so easily locate the crater from these types of events and the deposition that was left. These chevrons reach up to a ridiculous 40 meters or 131 feet high. In our next episode, things ramp up in intensity. South Australia has some areas where some pretty formidable damage exists. Massive chevron deposits, so tall that the vegetation has never been able to regrow. Evidence of this event increases in intensity before peaking in the northwestern parts of Western Australia, where the most significant evidence of this event can be found. And on top of this, I've made what I think might be the first discovery of what appears to be chevron-like shapes in Indonesia. Researchers have often noted how there doesn't really seem to be any visible damage that exists in India, Sri Lanka, or in Indonesia. And this is true. This wave damage is really evident in Australia, and then we see very little evidence again until it picks up suddenly in Pakistan, with only one region existing in India that I think might have evidence of a direct hit. I will explain my theory behind why these places didn't receive a direct impact like the Middle East, Africa, Australia, and as you will soon see, Indonesia maybe did. And it's a very fascinating story, and we'll be hopping from continent to continent, ending our series in Africa, after which we'll cover the global deluge that occurred from this event post-impact, before ending it there. So stick around and I hope to see you all there, because some of this damage in Indonesia is so immense, but the forests have completely hidden it. But once you see it, you can't unsee it, and I think it's really going to blow your mind. And I'm hoping to one day go there in person to prove this theory. Australia was hit by a devastating 180 metre or 590 foot high mega tsunami sometime around 5,000 years ago. The evidence left behind by this event is widespread and very obvious, and the scattered deposits left by it run across a staggering distance. that sees damage from this event popping up in southwestern Tasmania and stretching all the way up to this point in Western Australia. This tidal wave of truly epic proportions was generated by a comet impact that struck into a deep section of the Indian Ocean over here, spawning a giant mega tsunami that barreled forth in all directions. This is episode 3 in the series where we document the visual evidence left behind in present day from this event. In episode 1, we kick this series off with a deep dive into the impact, where we discuss how to identify the features before going on to document the significant damage left behind by this event, upon which the entire city of Perth is built. Then in episode 2, we travelled from the bottommost point of Western Tasmania, up through the islands in the Bass Strait, before heading to Victoria and documenting the evidence that was left there, before ending just before we hit the border with South Australia. In this episode, we'll begin by covering the incredible damage present in South Australia, as we slowly journey further west, documenting the destruction that was wrought and the depositions that were lain. And this slowly intensifies as we progress throughout the video, and as we go from South Australia through to Western Australia, where we'll then journey all the way up north, to finally discover what is by far the most spectacular evidence of this event that has been left behind in the very far north of Western Australia. On top of this, I'll also explain the difference between chevrons and the many aeolian deposits that we see all across Australia. And I'll also be outlining this video in a more evidence-heavy way, since I saw a few people were skeptical that these were chevrons to begin with. And this skepticism is definitely warranted and necessary. And in this situation, this skepticism came with some positivity, as the necessity to prove myself led to me attempting several solutions inside of the simulator to see if there was any way I could better show and illustrate the damage and chevrons that have been deposited all around Australia. And then I realised that by altering the time of day, the shadows cast by the sun at this angle lead to a highlighting of the chevrons. But not only that, by adding a snow function, I can further highlight the topography. And this has not only led to some incredibly stunning highlights of the chevrons, but it's also allowed me to track the wave damage much further than I originally did in my earlier assessments, now that I can better identify features on the land. So now, let's get into it. We kick off here at Cape Bridgewater, in the far western section of Victoria. These massive chevrons appear very clearly on Google Maps, and they stretch much further inland than the sand dunes suggest. A little west of Nelson is the beginning of the South Australian border, so let's cross over. In this part of South Australia, the high cliff faces and sheltering of this area has left little visible damage until we get to the point that was most impacted by the wave here, west of Port MacDonnell, around Shelley Beach. Massive directional chevrons smashed into this area and went many kilometres inland, depositing large sandy hills in the topographically low terrain. The largest chevrons begin after the visible sandy bits here, and they are quite massive, with them towering above the relatively flat land by 20 metres in some parts. At Canunda, we are treated to an exceptionally large and very long topographical low that displays the beginnings of the mega tsunami. These sandy hills are very impressive, but it's only when we dim the light that we can appreciate their bulbous topographical shadow. This really makes them pop. Notice how these shapes converge. Later on, we'll take a look at the difference between chevrons and aeolian shapes. And by aeolian, I mean wind-formed or wind-influenced deposits. A few comments stated confidently that these were aeolian deposits that I was covering. In this video, I will prove that to not be the case. And it begins by highlighting this joining that is the rule rather than the exception for chevrons. Keep this in mind, because it's important for later on. But it's not just the alteration of the sun that really makes this video different to the other two episodes. Oh no, it's the addition of the snow layer, because when we apply the snow layer, this happens. Look at the area behind the lake. We can now see the main extent and reach of the wave. The flattening of the land here by us humans might have led us to think the wave stopped before this massive lake here, but this is very obviously not the case. Another thing to note with chevrons versus aeolian deposits, as you will see here, is chevrons always have a point at which they stop, which is normally always abrupt. That point being the point when the wave loses its power, dumps its sediment load, and then begins to retreat. As we move on, There's an area that really caught my attention at Cowrie Beach, because of the very obvious horizontal lines that humans have excavated. It appears like they've flattened all the chevrons here because there's no agricultural land, and in between the excavator marks at places that weren't flattened, we see chevrons that were left behind. I can only assume this was an area that was prone to some pretty bad landslides, but if you live near here, or know or have a theory as to why we've done this, please let me know in the comments down below. Moving on now, and between Beachport and Robe appears very obvious and massive chevron deposits south of Lake St. Clair. This intense amount of wave damage and deposition stretches along this entire coastline, and is unbelievably vast. When this wave hit here, it would have been a truly cataclysmic scene to have witnessed. Now, from Kingston to Goolwa, we have the perfect situation to allow a mega tsunami to grow in height, as it ramped up and struck the shorelines of Long Bay. And strike it did, leaving a massive directional gash in the land from point to point, before suddenly stopping, as Kangaroo Island began to bear the brunt of the main wave as we approach Goolwa, further corroborating the fact that this is a mega tsunami, with areas being spared purely because of the direction these waves are travelling in. On Kangaroo Island, the evidence is clear. If this was an aeolian deposit, why is the locationing of these impacts perfectly in line with the impact centre in the Indian Ocean? And this will be very clear dozens of times in this video. At Porky Flat, obvious wave damage and chevrons occur. I mean, look at this, I can literally draw an outline of the main wave damage here. The waves went beyond this point, but this is the most significant outline, and it is an outline. This is a recent event after all. 5,000 years is a blink in geological time. These deposits become more intense at Seal Bay, where the damage is amplified as you can clearly see here. Breathtaking is one word to describe it. Holy f*** is another. The carving into the land is just unbelievable. Again, if this were aeolian, this is not how it'd look. The distribution, shape, and scattering is just not right. This is a chevron, and it's a chevron from the mega tsunami that was created during the Burkle Crater impact event. Look at these perfect clear chevron shapes. They are flawless. As we reach the western coastlines of Kangaroo Island, we're greeted by some extremely large chevron shapes. After this mega tsunami scaled a 150 meter high cliff face to get here, where it then deposited chevrons up to around 20 meters high. It followed this river system deep into the land too. Now we get to an interesting part of the story. I originally thought Adelaide was spared from the mega tsunami. Sorry guys, unfortunately it was not. It's amazing to see actually, because the wave just managed to hit Adelaide in the southernmost section of it. This again corroborates the fact that these are chevron related deposits coming directly from the Indian Ocean Burkle Crater epicenter, as this is literally just a small strip where the mega tsunami managed to navigate through Kangaroo Island to hit Adelaide, and hit it did. This is actually quite amazing to see. It wasn't so obvious until I altered the lighting and added the snow effect, and it's clear these two have been a game changer in reading the land and the deposits left behind by this event in a very clear and concise manner. It appears like this may be a sand quarry working on the chevron, and the clear cutoff points are here, with the tsunami barely making it through to hit this part of Adelaide. The land that sheltered the rest of Adelaide and bore the main brunt of the rest of the wave is here, and well, take it, it did. As you can see, this mega tsunami absolutely decimated its way through this island, inundating much of it, and leaving these massive visual reminders of the event. Now after this, near Port Victoria, we have some cheeky chevrons that have managed to make it through to strike here, leaving a large imprint of the event behind, which, when compared to the surrounding land, bears a striking difference. Now here is a good chance to discuss aeolian deposits. These thin strips here, all of which are directional based on the prevailing wind current here, were formed by wind and are wind-shaped and or formed. Unlike chevrons, the prevailing theme are horizontal lines that do not join. And when deposits like this do appear to join, they are always the exception rather than the rule. Meaning the most predominant shape you will find aeolian deposits in are these kind of strip-like lines, unlike chevrons, which are, as the name suggests, chevron-shaped. Thistle Island is where we journey to next, and damn, check out this intense directional damage. heavy chevron deposits occur in the northern part of the island. Now, this is another time to prove it moment. This is the clear direction the wave was travelling when it hit here, based on the chevrons. This means between this area, there should have been the tiniest, and I mean tiniest section of mega tsunami that made it through to hit the mainland. That would mean Port Victoria isn't the endpoint. But where is? Well, right here. A tiny area north of Port Victoria, where chevrons exist amongst an abundant aeolian-fueled background. After this, we move to Lincoln National Park, an area where the bay was enveloped and covered over by large sediment dumps. But that was nothing compared to the area you're probably staring at because it's sticking out like a sore thumb. This region in the west, which has the largest chevrons I've seen in South Australia thus far, with the most wave damage occurring in one location in my opinion. Coffin Bay has some of the most clear and distinct chevrons, and it's even more compelling when it's viewed under low light and with a snow cover applied. The shapes couldn't be more perfect, or more telling. These deposits are screaming mega tsunami in every possible way. As we leave Coffin Bay, we are greeted with the multiple other bays that were impacted as we journey westward ever more, with obvious alterations to the land that you should be an expert at detecting by now, especially if you watched all 3 episodes. The last piece of major wave-related damage occurs here, but let's not stop there, because what's hidden is so much more interesting than what is visible, as you can see. And this is the end of South Australia. We now cross over the border into Western Australia and head past Eucla, the first area where the wave-related damage begins, over here. It looks like barely anything happened here, but again, what's more interesting isn't what's visible. As you can clearly see, it was still submerged beneath a watery chaos in an instant, and chevron deposition did still occur, just to a lesser scale, with smaller and more numerous chevrons evident. Here, massive chevron deposits exist. The vegetation was plunged not only beneath a vast amount of salt water in a split second when this wave hit, but it was also surrounded by sand, and choked and buried alive by it entirely in some parts, as entire forests became covered over. As we look west, notice the very obvious directional wave damage. Every topographical low here has suffered the same fate. A vast burial by sediment, with large chevrons working their way inland, before finally tapering out at a similar point inland all along the coastlines here. Here at Albany, the giant wave was so high it actually flew over this cliff face over here, which has a topographical high of around 170 meters or 557 feet at the cliff face, where it then deposited huge chevrons here, before largely stopping at the bay's exit, with some finer sediment flows moving ahead of here. But at this point here, at Torndirrup National Park, there was a slightly lower topographical point of around 110 to 130 meters, which allowed a larger proportion of the wave and the sediment it was carrying through, where it then moved over these 2 islands, with the finest sediment from it being deposited when it made landfall here. How incredible would that have been to witness if you're in a plane flying over here when this wave struck? I mean, like, minus the damage and chaos and all that fun, boring stuff. After Albany, vegetation growth becomes more intense. This part of Western Australia is very lush, but even a perfect climate that is conducive to plant growth can't hide the scars of this event, with a large section of the island still so damaged from the wave impact that vegetation still hasn't recovered here yet. Massive bulbous chevrons dot this land, and it was actually this region here that took the main impact that otherwise would have struck the area of Albany much harder than it did, sparing it from the quite scary fate that occurred to this section of Western Australia. These chevrons are between 30 and 70 meters in size, or 98 to 230 feet. The cliff faces here bear some tremendous looking erosive damage from this impact, with chevrons dotted far inland from this point. Now get ready for it guys, because behind these cliff faces are the massive chevron hills that were deposited by this mega tsunami in the background. Truly spectacular. Northwest of here we have a similar level of damage, but some pretty large chevrons exist here in the higher areas, and we have these more smaller chevron shapes in the lower lying areas. From the northwest to the southeast, we have a varying level of topography, from flat land that is 10 or so meters high, before the terrain abruptly rises to a height of between 70 to 90 meters, where it then abruptly rises again here to a height of between 110 to 130 meters. I point this out because it's cool to note the differences in chevron deposition. The most impressive chevrons appear in the highest point, and as we get lower, it appears to get smaller and more numerous, which surprised me. I just thought it was cool to point that out. Unfortunately, much of the land surrounding the town of Denmark has been altered, so the slide that once existed in the topographical low here has been removed. But I imagine it would have been similar to these kinds of slides that we see occurring time and time again in topographical lows all around Australia. Skipping ahead now to the western shorelines past Walpole, we have this major tsunami deposit that has altered the land very dramatically near the area known as Broke. This would have been a lush green forest before this wave struck, and now it's an obvious and ugly scar jutting out upon the still wounded land. Check out those massive chevron hills in the background. They are very dramatic and prominent. A little northwest of here, and we have these beautiful chevron formations. Again, note the direction that they are pointing towards. As we begin to move north up the coastline of Western Australia, the direction will change from what it currently is, which is a relatively west to east path at this point, to a direction that points towards the northeast. This can serve as a point of confusion for anyone viewing these structures on Google Maps or Google Earth, as the aeolian processes that occur in the middle of Western Australia create vertical facing lines, and the chevrons are also somewhat vertical facing as we continue to go north past Perth. I'll point out the differences as we go, but the reason this has occurred is because the Earth is spherical, so we have to take that into account. But before we begin to press on, it's worth noting just how far the chevrons here surged inland. Look at this, it's incredible to see. This entire area was absolutely blasted by this impact, with the wave taking advantage of some substantial topographical lows of under 20 meters existing here, allowing the tsunami to stream inland with ease. Unfortunately, agricultural clearing and levelling has hidden much of the evidence of this event in the western parts of it, but obviously enough exists to tell us that this was, without a doubt, one heck of a chaotic event, and yet I can't help but wish that I witnessed it. Strange. As we move on, we have massive visible directional sand sediments deposited southwest of Northcliffe, and the impact damage clearly stretches from here towards Augusta. It appears that where we can see these large sandy sediment deposits, we have lower lying land, and we can expect to see chevrons further inland than normal. This appears to be the trend I'm seeing. They hint to topographical lows. After this point, we have this region here, which is more or less a cliff face from side to side, aside from a few areas where rivers flow out to the sea. This area ranges from 70 meters or 229 feet, all the way up to 190 meters or 623 feet at its highest point. We can see clear chevrons on the topographical highs here, with these ones existing on the highest elevation. When altered, we can see the chevrons that ascended these cliff faces on all points. These massive sandy deposits indicate a topographical low point, where the land begins at 10 meters high, before slowly rising up 160 or so meters. To the left are more fainter chevron deposits that have been cut through by a meandering river, that actually began its inception into life after this event and after these chevrons were deposited, and many stranded waterways exist on the topographical high points in the area just after these chevrons end. And this has occurred because this has dammed and isolated the former drainage networks, cutting off and stranding the pre-existing waterways. In the far north, bulbous chevron hills exist, predominantly in the more northerly parts. Moving on, and just south of Perth, we see the area where this wave damage recommenced. So you can see the directional aspect to this wave very clear, and I've pointed it out numerous times in this video. It begins here, moves up to Perth, and intensifies as we head north. We covered Perth in episode 1, so I'll just give you a cheeky glimpse into the chevrons here under the new lighting and snow display. This shot is located south of Perth CBD, around a Jandakot area. Here's one more taken in the middle to northern part of Perth CBD. Moving north to Gilderton, we're met with another somewhat clear low point. Chevrons stretch inland, and the town itself is basically built inside of these chevrons. The Gilderton sand dune tourist attraction are actually just these chevrons. Now, I'm not going to lie guys, I've traced chevrons that are very, very far inland, and I suspect this is from a past event that was, scarily enough, much more intense than this one. I don't care what anyone says, these are not of an Aeolian origin, in my opinion. I see small and large chevrons the same as I would with the Burkle crater impact around the shorelines, only these are 500 kilometers inland, which is 310 miles. This definitely warrants further study. As for this event, I'd be pretty confident in assuming it went 50 to 100 kilometers or more inland here, and in some places honestly it looks like it went double that. But it's hard to tell, because if there is another impact event that occurred relatively recently that surged 500 kilometers inland, well yeah, reading this is pretty confusing. The recent, more obvious and larger chevrons here definitely point to the recent event stretching for that distance, but it was definitely not strong enough to produce chevrons that could surge 500 kilometers inland. It was nowhere near strong enough for that. And one can only wonder what horrible, horrible event occurred here at one point in time that spawned a wave many, many kilometers high with the capacity to deposit chevrons so deep inside of Australia. I stopped at 500 kilometers, it kept going. So honestly, instead of just disregarding this, someone really should get out there and take a sample of it, and that's probably gonna be me, because I'm genuinely curious as hell to figure out what the fuck happened here. Moving past Gilderton, and we have one of the largest tsunami chevron deposits that I've seen thus far in Australia. Beginning after Brenton Bay and peaking at Wedge, these deposits are both tremendous and terrifying to see. The chevrons themselves are about 70 to 80 meters high. They inundated and altered this once flat landscape in a near instant. This incredible deposition stretches past this point, all the way up to and past Grey. It's amazing to witness these deposits in Western Australia because of how arid it is here, and how obvious these shapes are as a result. Soon we will take a look at the Aeolian processes, and how they both differ and interact with the chevrons that were deposited by this event. But what you are seeing are pure chevron deposits right now. Look at how far inland these guys go, and it continues beyond this point too, as is clear by the chevron-like shapes on the horizon. Now at this point, we are here. The aridity of the surrounding area will steadily increase from this point on, and the shape of the chevrons here is starting to become increasingly pronounced as a result. Check out how long some of these are. They just streak through the entire landscape, dwarfing it with their appearance. It isn't just long chevrons though. Just a little north of here, hundreds of smaller ones dot the landscape. We're at Lehman now, and this is where things begin to steadily dial up to max intensity. A large section of the land has been flattened out and built upon, which only serves to further highlight the dramatic difference between the giant deposits on the left to the smaller but more numerous ones on the right, as the wave began to push further inland. Very large and impressive chevrons exist beyond this point, the largest that exist in Australia in my opinion. The overall length of some of them is astonishing. The wave was able to just flow over this ancient, highly eroded flat land. Check this out, it's nothing more than chevron mountains. The sand from the event poking so evidently through, revealing itself in multiple chevron hillsides all over the place here. We have yet another two strips leveled by humans, allowing us to once again see just how incredibly hilly this land once was before this excavation was undertaken. At Kalbarri, the river system provided an excellent point of entry for this mega tsunami, which it readily took. The very pronounced chevron shapes show that clearly. To the west, the cliff face rises, and we see duller chevron shapes here as a result. The cliff face here was heavily eroded from this event, and this erosive damage is very pronounced for several kilometers. Check out this awesome chevron slide here. Yet another topographical low that the sediment slid into after scaling a cliff face and suddenly entering a flat terrain where the sediment just spread out in this beautiful fan-like shape. And finally, we are approaching the end of our journey. This is, in my opinion, the most visibly affected and damaged area in all of Australia, the coastline of Tamala up to Dirk Hartog Island. And you can see why I say that. I mean, look at this chaotic hellhole of an area. It's absolutely torn to shreds by erosive forces in some areas, and suffocated by massive chevron deposits in others. The cliff face is so straight too, because of how much it got smashed and pretty much instantly eroded when this mega tsunami hit. It's just the climax of this event in chevron form over here. These cliff faces are around 138 meters at their peak, with elevation slowly declining as we move north. And here we have many chevrons within a giant chevron. Very cool stuff. They are baby chevron. Now we have something very different and very cool. Check this out. What you are looking at here are massive chevrons. Duh. But inside the chevrons are sediments altered by aeolian action. The winds here have worn down the inside parts of these chevrons, and this has occurred as a result of their geographical location, with the westerlies hitting here hard. Aeolian action is the more straight lines, and the chevrons are the lines that meet. This is a perfect example of the difference between the two. There are many aeolian shapes that can be formed, but chevrons always look different in my experience purely because of the fact that chevrons are directional. They constantly shift their direction based on where they strike due to the fact they are originating from an epicenter and spreading outward. Aeolian processes do not do this. They trend with the direction of the prevailing winds. Eventually, in many thousands of years, these chevrons will be completely worn down, and these aeolian processes will take over as the dominant feature on the land once more. As we move further north, we begin to exit the area where the wave would have struck. These islands bear clear directional scarring in the bedrock here, and as we progress further north, the chevrons continue, leaving behind very large and distinct shapes. Notice how the direction of these chevrons has changed during the course of the episodes. The angle that it hit Tasmania at differs greatly from the rather upturned angle that it is now hitting this part of Western Australia at, and that is why this confuses so many people, and is why they rightfully mistake these chevrons for aeolian deposits. Many, including myself at the beginning, fail to take into account the curvature of the Earth when tracking the pathway of the mega tsunami. This is the area around the Cape Range National Park, and we have some really unique and awesome things going on here. Firstly, the video doesn't do it justice, but the chevron deposits at the bottom of the screen are actually at a topographical low, compared to the aeolian looking ones to the north of it. What we are actually seeing here are the almost completely eroded remains of chevrons from this mega tsunami event. The erosion was by aeolian processes clearly, and the reason this happened is because this entire middle section is at a dramatic topographical high point compared to the surrounding areas. So it has just been slammed by the prevailing winds here for 5,000 years since it was deposited. There are still some clear chevron shapes, but in a few hundred to thousand years these will be completely gone, and eventually the other, more preserved looking chevrons will follow its path and erode too. As we leave this area, we can see how this wave rode up a topographical low point, depositing numerous small chevrons, whereas the section of the wave that impacted the cliff face here had a much different pattern of damage associated with it, and the chevron deposits were more scattered, random, and different in their appearance, with them being more messy compared to the needle deposited chevrons in a lower land. So as you can see, the chevron deposition here is much more dramatic and obvious compared to the lusher parts of Australia. And after this point, the damage suddenly ends. We see nothing else. Aeolian processes take over, and that's what we're going to look at right now. What better way to end this than by showing you guys what an unaffected area of Western Australia looks like, where the prevailing modification placed upon the land is predominantly wind-blown. Here's one presentation of it. Notice how they are straight, and if they connect, it's the exception rather than the rule. Their appearance is drastically different to the chevrons we've covered in this series. These ones are curved, yet they look nothing like chevrons. And well, yeah, these are very obviously different. And now you've seen firsthand the effects that this event left over when it hit Australia. We've gone from Tasmania to Victoria to South Australia and all the way up to Western Australia in excruciating detail, documenting pretty much every noteworthy bit of land along the way. I hope you've enjoyed this journey. I've certainly learned a lot. If you have any idea where those chevron-like shapes that appeared over 500 kilometers inland from Western Australia came from, please let me know. Any possible impact events would be much appreciated. In the next episode, we're going to look at the chevron deposits that I found in Indonesia. Now, correct me if I'm wrong, but I think I might actually be the first person to have found and correlated these deposits with this impact event. If not, then all good, but I found significant evidence and I can't wait to share it with you guys. The next episode is going to be presented in a much more hurried state compared to the Australian series, and we're only going to cover the most prominent and noteworthy sections of the land purely because of the distance we are covering, as I intend on going from Indonesia, west past India, then south down Africa, covering Somalia, Madagascar, and ending our journey in South Africa.